we had seen different types of power electronic devices or power devices. So each device has its own, or each device has different power ratings. Power rating means what? Each device has its own current rating and voltage rating. And so if according to the voltage rating and current rating, of course, the power rating will also be there. Okay, so different applications requires different power ratings. So why we have so many electronic devices? Because each application, they require different power ratings, right? So for example, your mobile phone charger, it requires a different power rating. So you need some kind of step down transformer and you need some kind of regulators. So the power devices should handle such a 230 volt AC, and then it needs to convert 5 volt DC. If it's your laptop, so the power rating is different. If this is some kind of another system, let us say it's a fan or maybe the warmer pump, the heating pump. So the power rating of such devices, the power devices which we are using inside the warmer pump, that is different because the power is different. The power consumption of the warmer pump is maybe about 2600 watts or around 3000 watts. So you can imagine, so power rating is quite high, so we have to use a different device. So according to the application, you have to choose the correct device and correct power ratings of the device. So use the right devices for the right applications. So here I had given some power rating. So it's starting from 10 up to 100 mega. So the unit is voltage ampere. And here the x-axis is indicating frequency. So for example, up to 10 M level, you can use this thyristor. So thyristor can support up to 1 kilohertz frequency. So if it goes more than that, if your application needs more than that frequency level and the power rating is not a matter, but the frequency level is going more higher, then you can choose to use IGBT. For example, motor drives, you can use IGBT in the control circuit, in the PE circuit. For robots, some welding machines means in industry, they really use huge type of welding machines. So that kind of machines need some kind of power converter. So you can use IGBT inside. And some automotive industry also, we can use this IGBT and MOSFET, power MOSFET. The SMPS or a switching power supply or switch mode power supply, we can also use this MOSFET. And some home appliances, we can also use MOSFET. MOSFET is kind of cheap and best. So and it can withstand also quite some frequency, and also it can withstand quite some power. What kind of application you are targeting, then you have to choose the correct device. Why? Because each device has its own ratings. So here in this chart, you can see the rating of each device. For example, here SCR, it can withstand about 6500 volts up to 600 ampere. 600 ampere, you can imagine how high the current is. So normally in our home, we are using 10 ampere, 15 ampere. Even in some small scale industries, we are not going more than 40 amperes, 40. So 10 to 40 amps. Of course, if you have some special machines or something else, then that's different. For example, in a restaurant, they use a very heavy pizza oven and so on. So they have a different power rating and they use different current rating as well. Even for restaurants, I don't think they go more than the 60 ampere or something, because this 40 ampere is deciding your fuse. Okay, so now fuse, circuit breaker, these are another topic, so we don't need to change our focus. So right now you can just imagine 600 ampere means how high the current is. And also, for example, this company UPEC, they use SCR for this kind of power ratings. And Mitsubishi, Japanese company, They also use some devices like ACR and IGBT in their products. These devices can withstand up to 12,000 volt and 1,500 ampere current. So similarly, each device can stand certain voltage and certain current. So each company, for example, ABB is using a specific power devices in their products. So it's also depending on where they are going to use their product. So for example, in the oil and gas, in the offshore, you have to drill under the sea. So you really need a very heavy powerful machines to drill in under the ground. So then you really need a very high voltage, high current supply. So in that kind of situations, you need to control that high voltage and high current. So for that purpose, we can use these special PE devices. Okay, this is just giving you an idea. So here is the summary again for each PE device and its rating. For example, diode, so it can stand up from 1 ampere to 5,000 ampere or 5 kiloampere. So 1 ampere in our analog electronics or digital electronics, what is the current rating? It's in terms of milliamps. You can see it's in terms of milliamps. Here you can see from ampere to kiloampere. It's quite high. So that is why we call in analog electronics or digital electronics, we call this as a signal diode. In power electronics, we call the same device, but of course the construction is different. So we call as a power diode. Signal diodes and power diodes, you should know the difference. It's because of the rating. And of course, the voltage ratings, it can vary from 10 volt to 10 kilovolt. The slowest one is 100 microsecond. Fastest one can be 20 nanoseconds. You know, nanosecond is much smaller than this microsecond. So similarly, each device has its own power ratings, own current ratings, and own voltage ratings, and it has its own switching delay or switching time to change the state from one state to another state, from off to on, from on to off. So that is what we call as a switching time, how long it takes to switch from on to off to on. And FET, you can also see the current rating here, and also you can see the voltage rating, and IGBT similarly. So you can see that. So you can just read this by yourself. For example, if you are going to design some power electronic circuit, you have to decide first what kind of device you are going to use. Then you have to go to the data sheet of the device, because let's say now I am just going to build a circuit, power electronic circuit for my application, and I choose ACR as my device. In the ACR, I just go and type ACR. I want to buy this ACR from online. So I can go to the digikey.no. Digikey.com. Yeah. Or I can go to rscomponents.com or any other dealers who is selling electronic components. So they have the search box. In the search box, I type ACR. You know what will happen? I can see thousands of lines. So many devices will come. So how can I select which device I need to choose? So that is important actually. You should know how to select the device. So that is based on your application first. Maybe for me, I need only 10 ampere current rating, and I need about maybe 400 volt maximum my application will need. So I need about 400 volt, and I need 10 amps. So I can calculate the power. What's going to be my power? V multiplied by I. So that is going to be 4000 watts. This is the power rating I want, and I want SCR. So I have a long list from the website. So I have to choose the right one. So how can I choose? So maybe I prefer a second category. I will select manufacturer. So who are the manufacturer? Maybe I will go with some legitimate company who is a well-known company internationally. Maybe for example, I go with ABB. So then I just select the ABB products, and then I will just open, then there will be a data sheet there where you can download the data sheet of each device from this company. So maybe I will open the data sheet and I will check all other parameters which is satisfying my needs and so on. And I will see the IV characteristics and VI characteristics. If everything is okay, if I feel comfortable, or I will also see the similar application designed by other people, what kind of devices they have used, then I will select that device. I will buy that particular device from that particular manufacturer. Okay, this is just one practical tip. You can, when you design something in the future, you can always go to some websites when you buy the electronic components. You don't need to only buy these power electronic devices. You can also buy any other components in the same way. You have to check the data sheet because you are an engineer. You have to read the technical detail in the data sheet and select the right one. Here, some more parameters you can see for GTO and TRIAC and MCT. So what are the ratings? These actually, this is from the textbook, this page. So please go through the textbook. So you will gain a lot of new knowledge and information. This is not for the exam, but this is for your information. Okay, so power ratings summary. So here you can see different types of families, diodes, transistors, thyristors, and under each device type, there are subcategories, and you can see under subcategories, there is a further classification. So each device has its own voltage and current rating, and what is the upper frequency level, and what is the switching time, and what is the on-state resistance. So these all are important when you design the PE circuit by yourself, something new, innovative circuit. So please try to remember the symbol of devices, at least this diode and thyristor, and maybe GTO and IGBT and IGCT. Maybe it's not very important, but IGBT is important. These are a few more devices. For example, TRIAC. We use this TRIAC in some AC to AC converters. So IGBT is here. So you try to remember IGBT as well, and MOSFET as well. So these are some important devices that you may use in the circuits.